screen is just slightly off. There. Okay, counting problems. While we're doing that, how many different possible answers are there? Okay, so your diploma exam consists of 28 multiple choice problems and 12 numerical response problems. And so my question is, how many different ways are there to answer those 28 multiple choice problems? Right? How many possible, we're looking through, how many possibilities are there? Right? And because one year Alberta Ed came to us, this is back in the days of Applied 30 when there were 33 multiple choice problems, and they said, can you tell us where these students were sitting? There's a problem. The answers are too similar. Right, so how do they know if the answers are too similar? What's their criteria? So how are we going to figure this out? We've got 28 multiple choice problems. How many answers does each problem have? In your experience? 4, right? 4. Anybody done the SATs or PSATs or any of those guys? How many choices do they have? They have 5, right? Usually E being none of the above or something. You know, not always, but it could be none of the above or all of the above. But they have 5 choices. We only have 4. So how do we do this? What are the numbers going to look like? Or the pre-calculation numbers? You don't figure this out. Question 1. How many choices are there for question 1? 4. Question 2. Question 3. Question 28. That's equal to? You don't have to give me the number yet, but what's the calculator? What are you going to put in your calculator? How many times? And what's 4 to the 28? 16. Okay, so 9 is a billion. Right? A exponent of 9 would be a billion. 12 is a trillion. 15 would be a, I don't know, quadrillion, I guess. I don't know if that's actually a technical thing. So this would be 72 quadrillion possible ways of answering this, right? So they know that if a couple of papers are pretty similar, and it's not so much in the right answer, right? I mean, we are hoping students get the right answers, but it's more like, if they look and they say, hey, in these 10 or 12 questions that were answered wrong, they had the exact same wrong answer. That doesn't happen that often, right? There's just too many possibilities, too many ways to go wrong. You likely don't make the same mistake as another person. Right? So it turned out one person was sitting in front of the other and there was a problem. But they look at stuff like that. You just got to get 100% and then you're okay. There's only one way to get all the right answers. Okay, so big number, right? And that's a counting problem, right? You got to figure it out. How do I do this? It's not a permutation. Right? We're not arranging objects. Right? It's just a fundamental counting principle. Okay? I have 28 multiple choice problems. Each one has 4. Now you go to the SATs, that'll be 5. It'll be 5 to the 28, even more. Right? It's just huge numbers. And sometimes we get really huge numbers in counting problems. All right, let's remember n choose r, written as a column thing, which is equal to n choose r, which is n factorial over n minus r factorial, and npr, which is n factorial over n minus r factorial. Okay, so we've got these two formulas that we're going to be dealing with here, right? And so we may have to use them. Now, I showed you how you can do it on your calculator, right? So when you're doing the diploma, or if you're doing a multiple choice question that involves something like, 6p x is equal to 30, you can just plug that in your calculator and look in the table, right? You don't want to graph it, because if you graph it, all you're going to see is these little dots. And it's not really, look in the table and just say, I'm going to look down the table until I see a y value of 30, and then I'll look across, I'll find my x value, that's my answer to this question, done. Okay. But it's not always going to be that easy, right? So I'm going to ask stuff like, n choose 2 equals 21, and I want you to algebraically determine that, right? So you have to show some work. Just the answer alone, I will give you nothing, because I know you can just plug that into your calculator. So that's kind of trivial. So for this, it means we need to refer to the formula. So we're going to go n factorial. Oh, sorry, what? Yeah, I'm going to give you the formula sheet. Remember that I gave you the souvenir copy of the formula sheet. So if you look at that, that'll show you every formula. If you look at that, you just go grab one and make sure. See what it's done already. And probability, yeah, it's got definition of n factorial. N factorial equals n times n minus 1, or n minus 2, that's down 3 times 2 times 1, where n belongs to natural numbers, and it defines 0 factorial as 1. It's got npr, it's got ncr, and then it's got ncr equals nr thing, right? It's the alternate notation. So you have that. So start off with this, right? It's a equals 21. So that's probably a half mark, right? If there's nothing else, you knew that you've got to plug into the formula and you can do stuff. So what do you want to do first to solve this? Yeah. Multiply by 2. Let's get rid of that 2, right? And it's just this is a number. Whatever it is, it's just going to be a number, right? I mean, if it's in this form, where this is the unknown, then that number is going to be down here. And 2 factorial is just a number. So is 3 factorial, 4 factorial, whatever. So you're going to go n factorial over n minus 2 factorial is equal to 42. Multiply both sides by 2 factorial, which is just 2, get 42. Now we want to expand, right? We're going to do some expand and cancel. What do we expand? The n factorial or the n minus 2 factorial? And start with the bigger one, right? Which one's larger? Because a factorial always goes large down to small. Okay, so I'm going to expand the n factorial, so I'm going to just put the n minus 2 factorial on the bottom, and I'm going to start expanding. So it's n times n minus 1 times, okay, looks good, probably cooler too. What's next? N minus 2. What's next? Factorial, right? We're going to stop there. Remember, whenever we're expanding a factorial, you'd say 10 factorial is 10 times 9 factorial. Or 10 factorial is 10 times 9 times 8 factorial. Or 10 factorial. You can stop anytime you want. Just throw down that factorial symbol. I'm done. Okay, when am I done? Well, when these guys are equal. That's equal to 42. You must have brackets around these expressions, n minus 1, n minus 2, right? And if you don't, it really doesn't make any sense. Okay, now what? Cancel those. Whenever you cancel, you're always leaving behind a 1. Okay, now we're going to expand this, so we're going to get n squared minus n is 42. This is a quadratic. We solve that by setting it equal to 0. So n squared minus n minus 42 is equal to 0. They're natural numbers, so this has to factor, right? There is no choice. It has to factor. So n minus 7, n plus 6, Whenever you factor, the most important step is to check it, right? Because maybe you get your signs wrong. So we got n squared plus 6 minus 7 is minus 1, minus 42. Okay? Usually, 90% of the time, the numbers are correct. It's the signs that get reversed, right? So you know the numbers. I need two numbers multiplied to 42. But you get those right, and then you flip the signs around. So n equals 7, n equals 6, negative 6. What do? Cross off the negative 6. I want you to show it. So show me, hey look, n equals negative 6. That is the solution to the problem. But it can't be a negative, right? So we go with n equals 7. And now, how would you check that, right? Just go on your calculator and just go 7, choose 2. Hit enter. It says 21. You go, hey, that's right. Okay, I got it right. But I had to algebraically determine, right? If that's on a multiple choice, all you got to do is fill in each of the multiple choice answers, right? I mean, you try a 5 in there. Nope. Try a 6 in there. Nope. Try a 7 in there. Yep. Try an 8 in there. Nope. Okay, must be 7, right? So multiple choice, you can attack a little bit differently, right? You can also do this graphically. You can do x choose 2, and then just look through the table until you see 21 as the y value. But algebraically determine, this is how you have to show it, right? You got to show all that work. All right, how about n plus 3? n plus 3 choose 2 is equal to 28. Okay? We're going to substitute in for half a mark, right? I mean, if nothing else, even if you can't do the rest of it, you can still. So on any problem algebraically determined, at least get a start on it, right? Do something. Pull out a formula. Okay, so n plus 3 factorial over n plus 3 minus 2 factorial, right? Because this is my n and that's my r, times r factorial, which is 2 factorial, equals 28. First step, we're actually going to do two things, but what's one of the first things we're going to do? Multiply by 2. So I'm going to go n plus 3 factorial. I'm going to change this down here to n plus 1 factorial, right? And go equals 56. So all I've done is 3 minus 2. And then we multiplied both sides by 2 factorial, which is just 2. Remember, if that was a 3, and that was 3 factorial, I'd be multiplying by 3 factorial, which is 6. Okay, what do I expand? N plus 3, right? The bigger one. Okay, so I'm going to expand the bigger one, so I'm going to put the smaller one down here, right? Because I want to stop when I get to there. So n plus 3, what's next? N plus 2, what's next? What's next? Stop there. When you stop, put a factorial sign, right? In proper mathematical notation. Okay, cross these guys off. N squared plus 5n plus 6 is equal to 56. And so just multiplying out the binomials. Okay, two numbers that multiply to 50 and differ by 5. Double check. N squared minus 5n plus 10n will be plus 5n minus 50. N equals negative 10. Show it and then get rid of it. Right, I want to see it, and then I want you to reject it. And say n equals 5. We're done. Right? You could check it. You're going to check it by going 8 choose 2, right? 5 plus 3 is 8. You're going to do 8 choose 2. 8 choose 2, 56. Good stuff, right? If you were going to solve this graphically, you go y1 is equal to bracket x plus 3, then NCR, and then a 2, and then you just go into the table, right? But you would probably want to bracket this, because if you went y1 is equal to x plus 3 NCR2, it's going to do 3 choose 2, and then add the x to it. Okay, so you need to say y1 equals bracket x plus 3 NCR2, so that it uses that expression. Either way, if you had done it wrong, then just go back and check at the end, right? I mean, when you're done, if I did it wrong, then go and throw that number in. So I think n is 7, I get 10 choose 2. So, wait a second, that's not 28. Okay, well, what did I mess up? Right, oh, right, I've got the wrong, I need to put brackets around that thing. Okay, yearbook committee. Okay, you see a committee problem, we're going to be choosing people for committee. We have to ask ourselves whenever we do any of these problems, does the order they're chosen make a difference or not, right? So are they being chosen for specific positions, or are they just being chosen? The yearbook committee needs a group photo of 6 girls. They go to the foyer where there are 8 girls and 8 boys. Photo of 6 girls, we got to add to here, and 4 boys. Something got cut off the page. How many different groups of 6 girls? How many different groups? 6 girls and 4 boys. Could they take a photo? So, the question we got to ask is, does the order matter? Worthy of taking the sunglasses off. No, it doesn't, right? So the order doesn't matter, right? If the order mattered, we could ask something like, how many ways can we line them up, and then the order would start to matter, right? Because then we'd say, well, it's a different picture if it's lined up. We just want a group. Okay, if the order doesn't matter, what are we going to use? C or P? C. Okay, so how many girls are there? How many do we need? 6. How many boys are there? How many do we need? Okay, now you could have written it this way as well. Okay, so those are equivalent. Okay, what's 8C6 times 8C4? This is what you write, but this is what you got to put in your calculator, right? 8C6 times 8C4. Thank you. A good year, that, right? Now, there's a lot of different ways that this question could be asked, right? There's a lot of different stuff. We could say, well, the boys need to be together, and the girls need to be together, and the order matters. So then we would use permutation. I would say P6 times 8P4. And then we multiply that by 2. Because we could have the boys on the left and the girls on the right, or we could have the girls on the left and the boys on the right. So there's 2 ways to arrange the 2 groups. So you need to consider that when you're answering the questions, right? B, let's do another part. So if they decide to line the students up, in a row, with the girls first and then the boys. We're going to put them in a row, then how many arrangements would we get? So now, does order matter? Yeah. Okay, so what are we going to do? With girls first, that's going to be 8P6. And then the boys, 8P4. And this will be probably a few more than 1,960. Okay, so see, there's a couple of more ways we can do this if we make an arrangement. Right, like 33 million more ways that you can do this if we take individual, your place in the photo matters. If I just said if they decide to line the students up in a row with the boys together and the girls together, then you go 8P6 times 8P4 times 2, because now we don't know, well, are the girls on the left and the boys on the right or vice versa? So there's 2 ways we could do that, and we would take that into account. Right? So we'd have to multiply by 2 to say, well, but this one said girls first, then boys. Okay, so that's nailed down. 3. How many ways can the 5 starting positions on a basketball team be filled? And for clarity's sake, what are those 5 starting positions? Anyone? Come on. Okay, so we got like a center, right? How many centers do we have? So 1 center. What else do we have? Okay, let's just call them guards. How many guards? 2 guards and 2 forwards. It's so tough. I know you don't know baseball, but you ought to know basketball. So we have some in our midst. From a roster of 3 centers, 5 guards, and 6 forwards. Okay, now because I just specified 2 guards and not particular things, then does the order that the guards are chosen matter? No. Okay. So if the order doesn't matter, then we're dealing with we're dealing with a combination, right? Order doesn't matter. Okay, so how many centers do I have, and how many of them am I going to choose? Centers, where do I put? 3. Okay, guards, 5 and 2. Forwards, 6 and 2. Equals. There, let's go down. So 3 choose 1 is 3, 5 choose 2 is 5 times 4 over 2, which is 10. And 6 choose 2 is 6 times 5 over 2, which is 15. So we've got 30 times 15, which is 450. 450 different starting lineups you want. The team that has, 14 players on it, you've got to choose. Went all the way to 10.
No, I haven't before.
Thinking, wow, record time. How'd she do that? Number 4. How many different 5-card hands that contain at most 2 black cards? How many? A lot more fun than this. How many different 5-card hands that contain at most 2 black cards? Can be dealt from a standard deck of 52 cards? Question mark. We're going to deal 5-card hands because a lot of card games we play deal with 5 cards. Have to do with a 5-card hand. If I have at most 2 black cards, so a lot of English comes into math, as you may have noticed in the last couple of units, right? You got to figure out these ands and these ors and that. So if I say at most 2 black cards, then how many black cards do you have? Sorry. So if your hand contains at most 2 black cards, it could have how many black cards? 2, 4, 4. Okay. Now, we might say, well, maybe it's easier to count the other way, right? Because the other way would be 3, 4, 4, 4, 5. Okay, there's no winners here, right? Either way, we have to do 3 calculations. Okay. So remember yesterday we did the one with, well, we need at least 1 male. Well, let's just do the ways where there are none of them, and we can subtract that from everything, and then we get the answer. This isn't going to work that way. We just actually have to kind of add this up, right? So, how many black cards are there? 26. So what if we choose no blacks? Then how many red cards are there? And how many reds will we need if we choose no blacks? 5. Or, okay, so we are getting no black cards, or 1 black card, or 2 black cards. The word or is associated with the operation plus, right? So we're going to add. So what comes next? Okay, so we're going to choose 1 black card, which means we get how many reds? Or 2 black cards, which means we get how many reds? And we just got to work that out. You could do it all in one thing, right? Or you could work out each one individually and then add them together separately. Doesn't really matter. Like, I mean, I'll accept from you, this I want to see, right? If I'm saying determine, then I really do want to see this, right? I need to see that. I need to see you doing 26. I need to see the calculations you do. If it's multiple choice, then I need to pick the answer, right? So, good number. Yeah. As is a multiple choice question, this could come out looking like that. 26. Well, we might come out with C notation. It would probably come out with P notation as well. 26P0, 26P5. Right? And then at that point, you've got to ask yourself, well, does order matter or not? Like, am I doing a combination or a permutation here? Any numbers yet? 8. Like 8 over here?
Yeah.
Sometimes things move, sometimes they erase. Yes, no? I mean, I hate to have you have some incorrect answer in your book and then, come back to me in a few years. That question, that was wrong. It's been bugging me now for 2 years. I know, heavy on the basketball today. Like, go with baseball, but nobody out there knows baseball. You don't even know how many players are on a baseball team. Let's be chosen from 17. Okay, so it's tryouts, right? 17 people are trying out. There's 11 spots on the team. We want to know how many ways that this can be chosen. How many ways can this be done? If. Here's the ifs. Girls basketball. Maybe you didn't. And it doesn't actually matter. Do you really? Do they play basketball? Baseball, yeah. Nobody knew how many people are on baseball. Did you know? Just didn't want to say it. It's embarrassing. Okay, so if Jeff and Brent, then how many ways are we going to do this? Well, do you think it matters what order they're chosen? No, so it makes it a combination. Okay, so here's how we're going to do this. How many Jeffs are there? And how many of Jeffs do we need? So 1C1, right? Put that in there, even though you don't really need it. Put it in there anyways, right? Because we're going to call this is Jeff. How many Brents are there? And how many Brents do we need? Okay, and that's Brent. How many players are left, keeping in mind that these top numbers need to add up to the total players available. So there are 15 remaining. And how many do we need, keeping in mind that these bottom numbers need to add up to the total that we're choosing? Okay, so 15 choose 9. Really all you need in this is 15 choose 9, right? But by writing out the 1C1, you're saying, okay, here, look, here's Jeff, here's Brent. Now there's 15 players left, of whom I need 9. The only thing you really need to put into your calculator is 15 choose 9. Okay, I don't even know if I care what the number is. How much? 5,005. What if Jeff and Brent can't both be selected? Okay, so now you got to rack your head a little bit, right? Okay, they both can't be selected. Does that imply that one of them has to be selected? No. So that means either Jeff is selected and Brent isn't, or Brent is selected and Jeff isn't, or neither of them are selected. Okay. So I guess maybe we got to work out 3 things, right? Jeff is and Brent isn't. Brent is and Jeff isn't, which is really the same thing, right? It's going to be the exact same. Like one is selected and the other one isn't. Or the other one's selected and the one isn't. Or neither of them are selected. Okay, so choose Jeff. How many non-Brents are there left? We have 15 players left to choose from, right? Like, hey, Jeff, you're on it, and Brent, sorry. So there's 15 people, and how many do we need to choose? 10. Right, and this one is choosing Brent, but not Jeff, right? Or, so we choose Jeff, but not Brent, so this is not Brent. Or we choose Brent and not Jeff. Or, how many Brents and Jeffs are there? So we're not going to, so then it's what? 15. Choose 11. If you like, you can throw a 2, choose 0 in there, right? 2 guys, we're not choosing either of them. Right. That way the top numbers add to 17. We've taken care of everybody, right? Everybody's been accounted for. Oh, well, I guess if we were going to do that, then we should throw in here a 1, choose 0. Choose Jeff, don't choose Brent. Yeah. We don't always need that. And I don't think we need that. 2, choose 0 either. Okay, what's that add up to? So now I ask, is there an easier way to do that? Could just say, how many ways are there of choosing the player? So without regard to anything, just how many ways are there of choosing this team? 17, choose 11 ways. And from that, we can subtract A, and we're going to be left with B. Moving on. 6. Words. How many arrangements are there of the letters of the word monotonous? How do you spell monotonous? N-O-U-S. Which is not synonymous with it. So how many arrangements of monotonous are there? F. A. No further restriction. Okay, so how do we do that? Ten factorial, because there are 10 letters, right? But there are 4 O's. And 2 factorial, because there are 2 N's. Okay, so we need to divide out. Since we can't tell one O from the other, we divide by 4 factorial to take out all the arrangements of the O's. And we can't tell one N from the other, so we do the same thing. Okay, I don't even care what the number is, doesn't matter. Each arrangement begins with a T. So, it begins with a T, then what is it? 9 factorial over. Okay, so you just throw out the T, right? T's gone. Left with 9 letters, 4 of which are O's, 2 of which are N's, 4 factorial, 2 factorial. Each arrangement begins with an O. Begins with an O. Begins with an O. Can't I just take an O and just kind of put it away somewhere? If I do that, what am I left with? If I take out an O, there's still 9 letters left, right? 3 of which are O's now, so we take out that order. And 2 of which are O's. Or sorry, N's.
So we wouldn't have to take out all of those.
No. Now, if I say begins with an O, does that mean that it could begin with 2 O's? Yeah. How would I state it if I wanted to begin with O but not? Yeah, I'd say if it begins with exactly 1 O, then we have to go in, right? So we could just throw out the O and then say how many non-O's are there, right? And there's like 6 of them, and 2 of those are the same, they're N, so I go 6 factorial divided by 2 factorial, and then so on, right? And then finish it off. And I don't even know what that next part is. It got cut off. So. Okay, last one. A group of 4 journalists is to be chosen to cover a trial. There are 5 males and 7 females. I don't know why it's always split on gender. It should have like 5 from CNN and 5 from Schwab. How many possible groups can be formed? If at least 3 males. And in case you've already figured that one out, B, at least 1 female. And you can leave, so think about it, write down the answer, don't bother calculating it, just write it out in combinatorics notation, right? Write it out as something P something or something C something, and plus or minus, whatever, and but you don't need to work it out. Okay. So think about it. What are you gonna do? Okay, so what are you gonna do? 5 over 3. So 5 choose 3. 7 choose 1. There's at least 3 males. How many males could there be? Could be 3 or there could be 4. You don't need the 7 choose 0, right? You may see it in a multiple choice answer, you may not. Just be aware, it could be there or not. At least 1 female. What's the easy way to do at least 1 female? Minus 0 females. How do we do 0 females? That's the easy one, right? Otherwise, you're doing 5 choose 1, 7 choose 3, plus 5 choose 2, 7 choose 2, plus 5 choose 3, 7 choose 1, plus 5 or 7, you get it, right? Gotta do 5. This is everything minus no female, which means what's left must be at least 1 female. Right? Going back to 14b of whatever that was.